Geotechnical investigation is the investigation of the subsurface conditions, soil and groundwater, as it relates to some sort of site development, buildings, roads, utilities.
Now, why do people order these things? Like, what's the point?
We develop design parameters for other design engineers. So a subsurface investigation will tell you an allowable bearing capacity so they can make the foundations the right size so you don't get excessive settlement, things like that.
What do you not want to find when you're doing this kind of thing?
Soft, compressible, very wet soils, or organic soils. Those are things that can really adversely affect anything you put on top of it because it settles too much. Generally, a building can only tolerate about 1 inch of settlement, and when you put it on compressible soils and it's too much load, you'll get more than 1 inch, and then you get cracking of the facade, doors that don't work, windows that don't work, things like that.
What does a normal rig look like?
Normal rig is more like the size of a dump truck. That would have a large boom that comes up, probably 20-25 feet, and it would be just mounted on tires. So it would access a site that is probably more level and accessible than this one. The reason we have this rig on the site is it's all-terrain vehicle, and it can navigate the terrain, and a truck would likely get stuck out here. They're doing the exact same thing. Really, the important thing that they're doing is collecting the sample, and that is using a 140-pound hammer, falling 30 inches. And doesn't matter the type of rig, the small one or a truck rig, it still has that piece of equipment on it. That's our standard for collecting data. We take the samples back to our lab and you do strength tests on it, either unconfined compressive strength or grain size analysis. And we take that data, the lab, with the field data that we get on the 140-pound hammer falling 30 inches, and we develop our recommendations based on the strength of the soil.
And how deep do you have to drill?
It depends on the development. Roadway might be 5 feet, building foundations 15 or 20 feet, and heavily loaded buildings you could drill 50, 60, 70 feet.
Okay, so it is important to know what you're going to build here before you start doing this?
Yeah.
Okay. Are there different types of geotechnical investigations?
There's kind of a base investigation that would be the soil borings and lab testing and developing recommendations for site preparation and foundation design parameters. So if that's your baseline, yeah, you can add more exotic things to it. In-hole testing, in situ testing, resistivity testing, and other types of testing that might be more specific to, say, like a power station or some other type of development.
And how much time does it take to do this kind of job?
It depends on the amount of footage you're drilling. Generally, a rig will get 100, 150 feet in a day. Depends on the conditions, how easily it can move around the site. So in this case, we have 8 times 15, 120 feet. So they'll probably get it done in a day.
So when you say 150 feet, like linear feet or like square feet? Or
linear feet of drilling into the ground.
I gotcha. Yep. Say you find something you don't want to find. Is there a way to mitigate that?
No, there's always a way to mitigate it. It's just a matter of how big it is and deep it is and what type of development's going on it. But typically you can mitigate it with just some over excavation and replacement with good soil. More severe cases where it goes to a depth that's not really feasible, where you have shallow groundwater that you have to deal with, and digging a hole that deep is not an easy thing to do, then we may look at a deep foundation system. So there's always a way around it. It just depends on the cost of the solution.
What makes it cost more or less? Is it purely amount of coverage, or is it like your travel time to get there?
That's several things. Type of equipment. This type of equipment here with the ATV, it can't drive itself to the site. It has to be carried on a flatbed. So you have more equipment charge getting it to the site than you would with a truck rig. And generally there's a charge per mile on the mobilization, so distance. Outside of that, it's the amount of footage you drill on site.
Now, how does this kind of investigation differ from an environmental report?
Yeah, totally different things. Environmental phase 2, for example, would be environmental contamination. You're not looking at strength of soil for design parameters for engineers to design foundations. So in the geotechnical study, that's what we're doing. We're helping them design their foundations.
Have you ever found anything like shocking?
No, unfortunately not. No gold, no oil, no dinosaur bones.
Could that actually happen?
I imagine it could. You have to remember when we're taking a sample, it's about 1.5 inches roughly diameter tube we're pounding into the ground. So even if it were to hit an obstruction like that, you might not even recognize it by the time the little piece that you get comes up. So it's not a large sample that you get.
Those nationwide soil maps, how accurate is that?
We don't use those typically a whole lot in our line of work. I believe they were developed by USDA originally, so they're more agricultural leaning and upper soils. There are deeper geologic maps that talk about overburdened soils and then depth of rock based on mining data and well data from regions. But in general, neither one of those will give you a strength of soil. They'll give you a soil type or a soil profile. What we're doing is determining the strength of the soil to carry a load.
So really the purpose of those is pretty different from the purpose.
Certainly the USDA ones that give you a surface soil type is more agricultural, though it's used in civil design applications too.
Okay, so there's some crossover.
Yeah, there's some crossover.
Somebody like me, when I'm looking to buy a property, could I rely on that for anything?
Probably couldn't rely on it for design necessarily. You need to get site-specific information for each development.
Do people ever do this kind of investigation to determine whether there's wetlands, or is that just two completely different things?
Again, that's a different thing. Wetlands investigation is a different study. You're not looking at the strength of the soil for design parameters. You're just defining a protected area.
Somebody like myself, if I was driving by a property or walking a property, is there anything I could do to just visually inspect and identify problems or red flags without getting this kind of investigation?
Michigan Building Code will tell you, there's guidelines, Section 18 Michigan Building Code, that talks about geotechnical investigation. So it will tell you that you need to drill, but the building authority, local building authority, can waive that requirement, depending on the type of structure and what they know about the soil conditions at the site. So to drive by a site and make some assessment of whether it's good and buildable, generally higher and drier is good, lower and wetter not.
There are times then when a person could build and design without doing this. Basically, either if they wanted to take the risk or if the local municipality knows enough information.
It waives that requirement, yes.
Gotcha. And what does a geotechnical investigation not tell you?
Well, some of the things we talked about, the wetlands, protected areas, it doesn't tell you about the environmental contamination. It's easier to tell you what it does tell you than what it doesn't.
Yeah. Are there any other things that you wish people like me knew about these kind of investigations? Like why they should order them or what they don't do or anything like that?
I think most people recognize when they're building why they should order it. I hope certainly every site is different. Just because this site here is okay doesn't mean the one next to it is, okay? Probably the next thing I would say is important is it's not an exact science. Soil mechanics was developed by doing things 1,000 times and developing a curve, and we estimate what's going to happen when you talk about settlement. So it's just not an exact science.